Hi everyone, thank you so much for joining us today. I am the room captain for the sessions in this room. I'm Lindsay Marshall, I'm one of the product marketing managers at SAS, and I'm delighted to be your host for the sessions. So I get the pleasure of introducing everyone, and so first up today we have Joep Boom, and he is from Notalize, and he's going to give us a presentation around SAS Viya and large language models and the ability to enhance public sector efficiencies. So if we can all give Joep a warm welcome to the stage.
Thank you, Lindsay. Welcome, everybody. Good afternoon. My name is Joep Boom. I'm a data scientist at Notalize. And we are located in the Netherlands. We've come a long way. And I'm here today to talk to you about two use cases that we've been working on that use SAS Viya and large language models within the public sector. First, I'll give you a small introduction about our company, Notalize, and then we'll dive right into the use cases. And let's hope we have some time left for questions in the end. So Notalize, there we go. At Notalize, we are working to give our customers the most out of their data. We help companies become more data-driven. And we do that based on three different pillars. We have, firstly, a team of data scientists that can develop solutions in SAS and in other programs to get the most out of your data. We build ETL pipelines, etc. We have a team of software developers that are able to create custom apps to be able to view all of those insights. And we have a cloud team that we do hosting of all your SAS solutions in our own cloud. We have one cloud server in the Netherlands, in Amsterdam, and we have another one coming up in the USA. We have around a little bit more than 50 customers globally, and we are still growing organization. We have now a little bit over 20 people working for us. And we are certified, ISO certified, so we are able to handle any sensitive data. So without further ado, let's get into the first use case, which is a use case we did for the municipality of Huizen, which is a town in the Netherlands. At this municipality, they have a department that deals with requests for financial support. So there is people that cannot make ends meet, and they can request financial support from the government. And to apply for the support, they have to send in a bunch of documents to prove that they are eligible for the support. And along those documents, one important component is an analysis of the last 3 months of financial information. So bank statements. And currently they have a team of consultants that go through all these documents and they figure out whether you're eligible or not. And this is a very time-consuming process, and they have to go basically calculator in hand, go through this financial information and figure out whether everything is valid and these people are eligible. So they asked us, can we improve on this? And of course we can. So the goals of our project were to basically reduce the workload by automating this analysis of the financial reports, and by doing so also make it more accurate, because you can imagine that going calculator in hand might not be very accurate most of the time. Let's immediately dive into our solution and then later go into how we got to this particular solution. So we created a dashboard in SAS Viya, and in this dashboard, the first page is basically an overview of all the files, all the applications that people have sent in, along with the date and time of the application, the amount of documents that are in the application, etc. I know that the dashboard is in Dutch, so most of you will not be able to read it, but I hope it will speak a little bit for itself. In this dashboard, they can double-click on any of the files, and they dive into the specifics of that file. And they'll get a first initial overview of all the files that are sent in by this particular person. We also did some automatic detection of document types. You will see that in the second column. Some documents are automatically detected to be bank statements or application forms, that kind of stuff. And within, among these files are, in the bottom you see two bank statements, and there's a little check mark next to it. That means they're processed by our document processing pipeline and they are deemed valid. And if they want to dive into the specifics of these bank statements, they can click on the euro sign on the left, and they'll get to this page, which will show, in this particular case, there were 3 bank statements sent in. And on the right, you can see all green check marks, and those are checks we did in the background. One check is to see that the bank statements are valid, so all the transactions that we extracted from the bank statements add up to the balance in the end of the bank statement. The second column with the check marks is make sure that there's no double transactions, so there's no overlaps between the bank statements. We have to make sure that it's at least 3 months worth of bank statements. That's the third green thing. And then all the way on the right, we see that there are actually periods that are attached to each other, exactly. Sometimes people have to send 3 months. They send May, June, and then suddenly they'll send September, and they'll think, I've sent 3 months, but it's of course not correct. And along with that, we also have a general overview of money flows and most occurring transactions on the right. And from this page, the consultants can dive a little bit deeper into these bank statements with the 2 buttons in the top right. There's the calendar, which will take you to the timeline of the bank balances. And there's the scale symbol, where they'll be taken to a place where they can actually filter through the transactions and compare different things among each other to get to their conclusion. The first page you get to look something like this. You see a timeline of the balances on the left. And for this particular person, you see, for example, there's a big spike at some point, so you immediately see that might be an interesting moment to evaluate a little bit further. And on the right, you see basically the balance and the transaction difference per day. And then if they want to get even further, they go to this little scale symbol, and they'll get to a page something like this. This has basically been requested by them, so they have on the left and on the right, it's exactly the same. They can filter through the transactions and compare different types of transactions with each other and come to the conclusion about whether or not they're eligible. And they can filter on a whole bunch of different things. There's also some categories that we automatically detected, like the gas transactions or household expenses or groceries. And they can compare those to incomes and see whether it matches or see where all the money comes from for this particular person. And within the SAS Viya dashboard, we also created the ability to delete an application directly from the dashboard, which is also quite nice. And this product is currently in use by about 25 consultants, which is great. The key functionalities of this dashboard were that we added automatic document type recognition for a bunch of different documents. We created like a clear overview of the applications, and we did automatic processing of bank statements of all Dutch banks, so we're spanning only over the Dutch banks. And we added a bunch of automatic checks to make sure that these consultants don't need to do them themselves. So let's dive a little bit into how we created this, what's in the background. So we created a document processing pipeline where documents flow in from the application and they go through a bunch of different steps to end up in the dashboard. First, there's just a general check, is this file, does it contain any text? Because if it's just an image picture, there's nothing we can do with the text, so we just immediately put it towards the dashboard. If it has text, we use VTA to determine the category of the document. And then after we've done that, we rename the document and we transfer it to a location so that the document name is very clear, so it will say the document type and the application name within the document to make it much clearer for the consultants. Then if it was detected to be a bank statement, we have a bank statement processing flow in SAS Studio that uses VTA and Python, amongst other things, to extract all these transactions and put it all in one big ABT. And then we perform checks on this ABT, and we show everything finally in the dashboard. And I would like to look at a couple of these steps that were the most interesting. So firstly, we have the document type recognition. For this, we used SAS VTA with a pipeline, and basically the categories node in the bottom is where the magic happens. So this SAS VTA, they take all the text that is inside the document, they cut it up into words, and then you can basically perform categorization by the occurrence of the words. So for example, here's an example of what our categories node looks like. We have all these different document types on the left, and one of the document types is dependent on the occurrence of a couple of words. So if those words occur within the document, then it will be classified as that type of document. Pretty straightforward, but it works very well for these structured documents, and it's very fast, so that's great. Then, secondly, we go into the bank statement processing, which is the most impressive part of this project. So a bank statement looks something like this. And we have basically three different main parts. We have the information about the person, we have the information about the bank statement, and we have all of the transactions. And all of those parts are extracted using SAS VTA with different rules. And SAS VTA, you have the Liti language that you can use to extract entities and give them tags, and then use them in later processing within SAS. So for example, here we have the IBAN, the bank, what is it, international bank account number, and that's being identified by a couple of these Liti rules, in this case regex rules. And this concept node is then used inside a SAS flow right here. So we have a custom step that basically scores any document that comes in, extracts all of this information, and then it's processed into three different tables, one that contains information about the person, one about the bank statement, and one about all the transactions. And we combine it all into one final table that we can then use to perform the checks on. But this looks beautiful, but unfortunately, not all bank statements are created equally. So this is two different bank statements from two different banks. And one example is that all the headers are in a different place and a different name. So this, because of this, we have to make a different flow for every different bank, because it's all formatted differently. And most importantly, on the left, we see at the transaction side, we see that somewhere it says bij or af, which is Dutch for added or subtracted. So if we use SAS VTA to get that information, it basically says whether it was added or subtracted. But on the right, it's a different column, and there's no plus or minus signs or anything like that. So if you just purely look at text, you will just not know whether it was added or subtracted, which makes it a little bit difficult. So for this, luckily we had Python to help us. We used Python and a package called Python Plumber, where you basically define lines in the document, and then it extracts the textual information in a table format that you can then use in SAS. And in this way, you can see by the column whether it was added or subtracted. And it is quite a time-consuming process because you have to define all these lines. They have to be exactly in the right location. So preferably, we would use SAS VTA, but unfortunately for these statements, we had to depend on this. And then for this bank statement, we again created a flow. So this is the flow for these types of bank statements. And the only difference actually is that we call Python in one of our nodes. And the rest of the steps are basically all the same. The headers are still extracted using VTA, and the information about the person also extracted using VTA. Then the checks we perform afterwards. So here on the left, we have the shape of all the ABTs that flow out of all of these different flows for every bank statement. And in the left side of the flow, we combine all of those tables together, and they all have the same format, so that works beautifully. And then we, over here, we perform the checks. So we check, do the balances all add up to the exact amount? We check, are there no double transactions? And we also check if the period is correct. And then finally, in this part, we perform all the categorization that we saw earlier about whether a transaction is a gas or grocery or household expense. And all of it combines into a final ABT that we can then use in our dashboard. So this is a very useful dashboard for these people. Compared to doing everything by hand, they have all of this information available within SAS. And from this particular project, we have a couple of key values. Firstly, from the test period, about 95% of bank statements that were sent in by applicants were actually processable. So some of them were people that took, for example, if you take an image with your phone of a bank statement, then there's no textual information embedded in the document, so we cannot subtract that. But of the documents that were actually containing information, we were able to 100% correctly evaluate the bank statements. And these consultants estimated to be 65% faster coming to a conclusion about a case. So that's a massive reduction using SAS. Of course, every project is a work in process, so we have some next steps for this project. We want to improve on the categorization to be able to give them even more speed up in their process, detect more document types. We want to collect feedback from the consultants about how they use our dashboard, and maybe there's certain filters that they always have to click and use, and basically they're using all the same filters, so we can maybe optimize the dashboard to make sure that that's a page on its own, to make it even faster. And we are aiming to expand this project to multiple other municipalities and other sectors. So that was the first use case, and let's dive into the second use case. This is a use case we did for a federal agency in Belgium. It's a federal agency that deals with laws, laws on labor, so laws that are responsible for employer and employee relationships to make sure everything is done correctly there. And this agency, one of the things they do is they have a team of legal experts that get questions from civilians in the country, and they answer these questions in accordance to the law. So people ask, am I allowed to bring a dog to the office, for example? And they say, yes, you are, because of this law. And one important thing here is that when they get the same question multiple times, they need to give the exact same answer, because they need to be very consistent with the advice that they give. So to do this, basically they have the pipeline of receiving a question, then they plow through a Q&A database that they set up themselves with previous questions and previous answers. They find things that were similar, and then they formulate an answer. And they already have a system for this. They have the database set up, but it's quite a basic search system. So they have some limitations that they wanted us to tackle. One of them is the problem that Belgium in Europe is a country where they speak both Dutch and French. So sometimes they get questions in French, sometimes they get questions in Dutch, but they want to be able to search for previous questions in both languages, get both results, so they can be consistent among both languages. Also, their search system that they use now only allows searching for one keyword. So if you would type multiple keywords, it would see it as one giant string, and then just search for matches of that exact string within the database, which is not very efficient, of course. And they wondered if they could search based on articles and laws that were mentioned. So if they figure out, oh, this particular law matters in this case, they want to find out all previous answers that they've given based on that exact law, which they couldn't do now. And next to that, they have some manual labeling of the documents that they do, and that they also use for searching through the database. And they were wondering if we could automate that labeling in a predictive manner. And for these customers, we created basically two tools for them to use. One tool was a RAG solution. So this uses large language models to be able to type in any question and then find any relevant documents based on large language models. And secondly, we also extracted law references from the text, and we put it all into SAS to be able to filter on it as well. So let's quickly take a look at these solutions and then dive into the tech behind them again. The first solution is basically a chatbot where you can write a question in any language, and it will give an answer in that exact same language and quote previous documents that it would deem relevant. So here you can see someone who asks a question about how many days of foster care leave they're entitled to, and the system says it's 6 days, and these are some quotes from previous documents that this is based upon. And as you can see, the quotes are, some are in French, some are in Dutch, but the answer is given in English, so it understands different languages as well. And if you click on one of these documents, it will just pop open in a new tab. So these law experts, they can manually reveal if the answer is correct within the documents very easily. So this they found very awesome. How does this work? So to build such a system, you first have to do some pre-processing. So you have a large set of these documents, of these questions and answers, and we cut them up into small chunks of information. That's a crucial step because this matching that we're going to do has to be based on certain facts within the documents, and a document can have many, many different facts. So choosing your chunk size is very important because it needs to basically encompass one fact, but also have enough context to be able to for the large language model to understand the context around that fact. And these chunks are then stored in a database along with some embeddings in a similar way that large language models use embeddings. Then if a person asks a question, we can use a semantic similarity search within the database. So we take all of these small chunks of information that are relevant to your question, and we pass all of those chunks to a large language model along with the question. So basically we create an automatic prompt that says you have, you're allowed to use only this information that we now provide to you, and base your answer purely on that. Plus, we would like you to give quotes and say exactly which parts were relevant. And then we process that large language model answer, and we create the final result. This is great because it uses not pure keyword matching, but it uses semantic context to find documents. So if you're talking about a dog, you will not only get documents that are related to dogs, but also to pets in general, for example. It will find that context, and it will also not only find the documents, but it will generate an answer based on the documents, and it will quote the sources, so you know that the large language model is not hallucinating, which is great. Secondly, we made that other tool, which is a SAS Viya dashboard, where basically it contains all of the documents in their Q&A database. They can filter through it, they can select it, they can open it. They have all the functionality that they had in their previous filtering system, along with law reference filtering. So they can select a law and they can find all documents that have mentions of that law. And to find these law reference, we again used large language models in a clever way. Basically, by just asking the large language model, here's a document, find all law references, and give them to me in this particular format that we can then process within SAS. And that works beautifully. It will, within any document, it will perfectly find all the law references. You can tell it to put all the law references in Dutch, or you can tell it to put them all in English, and then all of it can beautifully be combined in the dashboard. And with both of these solutions combined, we basically tackled their limitations. Firstly, we can search in one language and get results in 2 languages. Well, actually, we can search in any language and get results in that language with quotes from any language, which is great. We can search on multiple keywords because you can just type a whole paragraph if you want, and it will use semantics to find similar documents. We extracted these articles and laws, and actually with these 2 solutions, these legal experts found that they did not need those manual tags anymore that they added themselves. So this final limitation just completely falls away. And we have another happy customer. So what I talked to you today about is basically 2 use cases, but 3 solutions. One solution that's purely based on VTA in SAS Viya. One solution that is a RAG system that is purely based on large language models, and a solution that uses large language models and the result of the large language model processing in a SAS Viya dashboard, a combination of the 2. If you think that sounds awesome, let's get in contact. You can find us online, or we also have a booth here in the Innovation Hub in the partner section. And that's it. Any questions?
You mentioned that you're pulling quotes from the documents and displaying them Thanks. Test. You mentioned that you're pulling the quotes from the documents and displaying the quotes as part of the response, as kind of partially as a guard against hallucination, but I was wondering if you ran into the situation where the quotes that were coming back were hallucinated. And I asked because this happened to me yesterday.
Well, we've had situations where the quote is not an exact quote, so it's slightly deformed, but basically like different phrasing, basically. But we haven't really encountered situations where it's completely different from any of the provided context. Yeah.
The documentation that you got for the legal documents, are they a finite set of documents that's created by the Belgian government, or is there documents that's randomly available in the internet and then you have to pull them and create a source out of it?
They're a database that they have within the government, which is also publicly available. And so if we got it provided to us, but also if they get new documents added, we process them again and add them to the solution.
The source is actually provided by the government, and then you parse those documents to create a database.
Exactly, yeah.
Okay, thank you.
No worries if you don't know the answer to this one, but
That's me.
do you happen to know if like documents with large numbers of footnotes affect your retrieval and recall?
Well, I would mostly when you have a document and you extract the text from it, it basically goes from the top down. So
Linearly.
if you have a large footnote, it could be that the information that was just above the large footnote, which continues in the next page, suddenly interrupted and will not end up in the same chunk, even though it's actually contextual information that's very related. So it could be that in that case, some of that information will be lost, yes.
Okay.
Yeah.
Thank you.
I can get you. Is this on?
Have you experimented with optical character recognition? You talked about some documents being images, and that's one tactic, supposedly, to render them into text and then try and analyze the text.
Right, yeah. So basically that would be an OCR solution. So you take an image and you want to extract the text from it. For this case so far, we didn't look into that because most of the documents that were actually sent, the PDFs, they actually contained text themselves already. But for the 5% that didn't, it is definitely a next step to consider, yes.
No more questions? Okay. So I'd really love us all to give a big thanks to Joop. And if we could also, before we go, make sure you give your feedback on the app for our speaker sessions, and we'll start again in here at 2 p.m. So let's give it up for you. Thank you, guys.
Thank you.